So welcome back, and we're carrying on with our study of exponents. Let's dive straight back in, and we are on page 23, and we're looking at this question over here. If you haven't tried it yet, then please pause the video and try it. Otherwise, let's have a look at it together. All right, so on the numerator, we've got 8. It's a normal 8 and 3. 8 times 3 is 24. Those are normal numbers without exponents on. Now we're going to look at the powers. We're going to look at the numbers which have got a base of 2. There's 2 to the power of 3 and 2 to the power of 2. When we multiply numbers with the same bases, we add the exponents. Okay? Just to remind you, what 2 to the power of 3 means is 2 times 2 times 2. What 2 to the power of 2 means is 2 times 2. How many 2's have we got altogether? We've got 5 2's. What's the shorthand for writing 5 2's? 2 to the power of 5. Okay, it makes sense. It always makes sense. Now we've got we've got a 5 to the 5 and a 5 to the 1. Total values, 5 to the power of 6. There are 6 5's all together on the top, multiplying together. On the bottom, we've got a normal 4 and a normal 6, that's 24. We've got 2 to the power of 5. And we've got 5 to the power of 5. Okay, now let's take a look at what's going to happen here. 24 divided by 24 just goes in once. We can divide the top and the bottom by 24. Now, 2 to the power of 5 times 2 to the power of 5, we could just divide those out and just get a 1, all right? Or you might say, but don't we know that when we divide with the same base, we subtract the exponents? Absolutely, all right? What about the 5's? Well, we're going to get 5 to the 6 minus 5. We're going to get 5 to the 1. 2 to the 0 is 1. So we end up with 1 times 5 to the 1. We end up with just 5. Okay. Right, let's try this next one. The next one's very similar, although it does involve some integers as well. In this next one, we've got negative 2 times 4. That's negative 8. We've got 2 to the 3 times 2 to the 2. That's 2 to the 5. We've got 3 times 3 to the 6. That's 3 to the 7. Okay? We hope that you realize that we're always working downwards, right? And we're always underlining our answer. On the bottom, we've got a negative times a negative. We've got a positive 12. We've got 2 to the 3 times a 2. That's 2 to the 4. We've got a 3 times a 3 to the 0. That's just 3 to the 1. So 3 to the 1 plus 0. Okay. And now we can simplify this. All right. This is going to be, we can simplify this because we're going to divide the top and the bottom by 4. We're going to get negative 2 over 3. And then we've got our 2 to the power of 1 and a 3 to the power of 6. Okay, now negative 2 times 2, negative 4, and 3 to the 6 divided by 3. What powers on that 3? 1. What do we do when we divide and our bases are the same? We subtract the powers and we get 3 to the power of, we get 3 to the power of 5. Okay. Right, so far we've established kind of 3 rules. Well, 2 rules and 1 definition. This one, the first one says that when we multiply numbers with the same bases, we add the exponents. Let's write that in words. When we multiply numbers with the same bases, we add the exponents. Right? The next rule says that when we divide numbers with same bases, we subtract exponents. Okay, and then we've got a definition that says any number raised to the power of 0 is 1. So now we're going to establish two more rules. The first one looks like this. Here we've got 2 times 3, and then we are squaring the result. Let's look at what that actually means. It actually means 2 times 3 times 2 times 3. Because remember, squaring means to multiply by itself. Okay, now if we take these brackets out, what we've actually got is 2 times 2 and 3 times 3. Okay, we'll do another one and then we'll take a look. This time we've got 2 times 3 times 5, and we're going to cube the result. That means take 2 times 3 times 5, multiply it by itself, and multiply it by itself again. Right, now if we look at what we've got here, we end up with 1, 2, 3 2's multiplying together. 1, 2, 3, 3 3's multiplying together. And 1, 2, 3, 3 5's multiplying together. Okay, so let's just look at what's happened. When we've got a product and we raise that product to a power, then both of the factors get that power. So in other words, here the 2 gets squared and the 3 gets squared. Doesn't matter how many terms there are in our product. Here we've got 2 and 3 and 5 multiplying together, and we're cubing the answer. The 2 gets cubed, the 3 gets cubed, and the 5 gets cubed. Okay, so let's just read what this is saying. Let's read it in words. When a product, a multiplication sum, is raised to a power, then all the factors get the power. Right, so we can write it with letters, with symbols, with variables. A, B to the power of C is A to the C, B to the C. In other words, when we've got something raised to a power, both things get the power. For example, if we had 2 times 6 and we raised this to the power of 5, then the answer would be 2 to the power of 5, 6 to the power of 5. Okay, notice we're just using symbols, actually called variables, and we're going to learn more about variables later, just to communicate this pattern. Right, really important idea is that when we add two numbers and square them, square the result, that's not the same as a squared plus b squared. Okay, I'm going to just demonstrate that too. For example, if we've got 2 plus 3 and we square that, 2 plus 3 is 5. 5 squared is 25. This is not the same as 2 squared plus 3 squared. 2 squared is 4, 3 squared is 9, 4 plus 9 is 16. Okay, not the same. Right, so our new rule is talking about products raised to a power. Okay, next up we're going to just see what happens when we've got a division raised to a power. In other words, a fraction raised to a power. Which one do you think is going to get the power? The top, the bottom, or both? Well, let's see, and we're going to work this out by writing out what does it mean to square something. It means to times it by itself. So we get that. Now, 2 times 2, 2 squared. 3 times 3, 3 squared. Which one got the power? Indeed, Impala. Both of them got the power. 7 over 5 cubed. let's take a look what happens here. 7 over 5 times 7 over 5 times 7 over 5. How many 7s have we got altogether? We've got 3 7s. How many 5s have we got altogether? We've got 3 5s. There's our final answer. Which one got the power? Both got the power. Okay. So when a quotient, and this should say, sorry, not a multiplication sum, a division sum, is raised to a power, then both the top and the bottom get that power. Okay, so we've written it in symbols here. But let's just do another one without symbols. Let's just do another. If we had 11 over 3 and we raised that to the power of 4, then that would be 11 to the power of 4 over 3 to the power of 4. Okay, so we've got all these rules. Now we're going to try and put them all together. Okay, and we're going to try and practice them all together. We'll do the first example here together, and then we'll ask you to pause the video and try some yourself. All right, first thing over here, we've got 2 times 3 to the power of 3. Which is going to get the power of 3? They both are. 2 to the 3 times 3 to the 3. Then we've got 2 to the 4, and we've got a 3. On the denominator, sorry, the bottom, we've got 2 to the 3, we've got 3 to the 2, and we've got another 3. Okay, let's now apply our very first rule. When we multiply numbers with the same base, so we're just looking at this number over here and this number over here, what will the answer be when we multiply those? That's right, it will be 2 to the power of 7. Now, let's multiply the 3 to the 3 times this 3. So in other words, we're multiplying this number by this number. Okay, and remember that that little 3 there has actually got a power which we haven't bothered to write of 1. So how many 3's are there all together multiplying together here? There are 4. What's our shorthand for writing 3 times 3 times 3 times 3? It's 3 to the power of 4. Okay, on the bottom, this is on its own. It's the only one with 2's in, so let's leave that. Let's look at these two. We've got 3 squared and we've got 3. And again, this 3 has actually got a 1 on it. So how many 3's are there on the bottom? Well, altogether there are 3 3's multiplying together. And the shorthand for that is 3 cubed. Right, now we are doing some division. When we divide and our bases are the same, we subtract the exponents. So 2 to the 7 divided by 2 cubed, 2 to the 4. 3 to the 4 divided by 3 cubed, 3 to the 1. Right, do I need to write the 1? No. Is it wrong to write the 1? No. Is it simpler to leave the 1 off? Yes. Okay, right. Before the next lesson, we're going to ask you to try the rest of these questions, B, C, D, E, and F, and we'll go over them next time. We look forward to seeing you then. Have a great day.